What up, nerds? I'm Bryson. You can call me Bammed, and this is CTF and Cigars by Bam CTF, where I light up a cigar and I talk about CTFs, hacking, and other security-related topics. It's been a few weeks. I've been busy. Saturday mornings are usually pretty clear, but not always. But hey, I'm back. So this week we are going to talk about some more of that proxy logon exchange ransomware. I think the last time we looked at Deercry, which was ransomware that was utilizing some pre-existing web shells that have been dropped by some other groups, um, using the exchange proxy logon stuff. Um, but yeah, this week we're gonna look at another one, which is Black Kingdom, and this group was actually using the exploit. So there's a little bit of difference there. The Deer Cry group, they were using existing statically named web shells. The Black Kingdom group, they were actually exploiting it. But we're just gonna take a look at the ransomware bit of that. We're not gonna look at the entire hack, not look at the web shells, just the ransomware. Shouldn't take too long. It's not really a complicated piece of software. We can actually decompile it to the original Python pretty easily. That only take us a couple minutes, and then we can just kind of take a look at the Python itself. But before we do that, let's light up a cigar. So what have I got this week? Let's see. This week it's an AJ Fernandez Diesel Rage. This is a Toro, so this is going to be 6 inches long and a 54 gauge. So this is a medium to full strength cigar. It's a little different than some others. Usually the wrapper is somewhere around here, about the couple inches from the foot. Sorry, not the foot. Anyway, from the cap. But this one they just wrapped it around the foot here. So let me go ahead and get this off. We won't be able to light it till we get this wrapper off. I know this. Yeah, there we go. It's coming off. Not quite in one piece, but there we go. So yeah, this is the Diesel Rage. All right, so let's see. So this is oh, it smells really good. It's a kind of fruity, bit of chocolate, coffee, kind of floral. Um, go ahead and give it a cut. I'm just going to go ahead and use a straight cut this week. All right. We'll do the cold draw. Okay, so a little more chocolate. It's a little spicy. Some black walnut. A little bit of sweetness to that. All right, let's go ahead and light it up. So I don't think I've had one of these before. I've had some other diesels, but not the Rage. I didn't realize when I pulled this out, I thought it was actually a different diesel, and then I turned it over and saw the Rage on the other side of the wrapper. Should be pretty good. It's pretty cheap. You can get these on Cigar Bid for $5 or less. All right, let's give it a try. So there's a bit of pepper. There's quite a bit of pepper there. Really peppery. Pepper with some chocolate. It's definitely spicy. I like this. It's just a little bit of coffee, a little bit of cedar, a little bit of vanilla. It's pretty earthy. That's pretty good. So we'll see how this goes. I did look up some reviews. What I can expect later, it looks like definitely more of the chocolate creaminess. Um, During the second third, some people are saying they're getting some malt. So I haven't tasted that yet. So we'll see if we get that. And then the last third is more chocolate, creamy, coffee, and the spiciness flavor. So it's pretty spicy most of the way through, but it kind of fades out near the end. Yeah, it's pretty good cigar. Um, all right, so now that we've got that lit up, let's take a look at some ransomware. All right, so let's see. Do I have that copy here? I do. So here's my file. This PIQKYZJED blah blah blah. All right, so it shows up just as a 64-bit PE32 or yeah PE file. It is for 64-bit architecture. And the thing about this when and I don't remember where I first discovered this, but it is a Python or it's a compiled Python um, binary. So when you run it in Windows, what it does, it actually first will extract a bunch of PYD files to a temp directory. PYD, those are compiled Python libraries. So it's not actually the binary itself or the original Python script, but all the different imports that it makes. They are exported as PYDs. Again, they're still compiled, but they're actually regular libraries. I did look up some of the hashes, and they are just the normal official Python libraries there. I didn't think about it, but I probably should have had a Windows system up so I could show that to you. But anyway, you can take my word for it. It goes in the app data directory in a temp under app data in Windows, and then it creates a directory called MEID with some random characters, and then it extracts everything to there. So think of PYD files like Python DLLs, but they are compiled. So essentially, if even it is built on Python, it's all based on Python. But if you don't have Python installed, that's why it's got to include all those libraries in the PYD format. And in this case, it was compiled with PyInstaller. And so that's part of what PyInstaller does. So I think that was how I discovered it when I saw that it extracts to the MID directory. Did a little bit of research into different ways you can compile Python, because it's pretty obvious with the PYD files that this was compiled Python. Look at some different ways of doing that, and the PyInstaller creates that MEID directory and extracts everything there. So we know it was Python. We know it was used with PyInstaller. So the question is, can we then decompile it to the original Python? And as it turns out, yes, we can, and it's actually pretty simple. So we are going to use this PyInst extractor. Like I said, it was PyInstaller, so this is the PyInstaller extractor. You can find this on GitHub. Yeah, if you just Google PyInst extractor, you should be able to find it. It's not that hard to find. I found a bunch of different versions. It is important that whatever system you're running it on, you do want to have the exact same version of Python that this thing was compiled for. When I was first trying it on my MacBook, I had I had Python 3.9, and it told me that it needed. I mean, actually, the PyInst extractor told me that it needed Python 3.7. So I'm logged into a system I've got in AWS, and we're going to use that instead because it's using Python 3.7. And I don't know if you've tried it, but managing different versions of Python on a Mac can be a nightmare sometimes. All right, so this is pretty simple. There's a README. Let's take a quick look at the README. Let's see how this works. So yeah, we just call the Python script, the PyInst extractor, and then the original exe, and it will extract things. So that's pretty simple. We are using Python 3. Let's double check our version. Yep, 3.7. 3.7.9. I'm pretty sure that was the version it was compiled with, if I remember correctly, and all that worked perfectly. So we're calling PyInst extractor, and then now let's see, the file's up a directory. Done. Now this isn't going to be the final step. There's going to be another step after this, but This a bit essentially is just unpacked it. So when with the way PyInstaller works, it compiles everything. So it compiles all the libraries, compiles the actual script itself, and then it packs it all together into an executable. And when the executable is called, it unpacks everything, and then it spawns a new process with the extracted content and runs that. So what we've done here is just the original extraction, and then we still need to decompile. And you can see here's all of our files. And if we go through here, these are all, if we can check these hashes if we wanted to, these are all valid files, but there's one that stands out, and it's this 0xfff.pyc. So the pyc file is a compiled Python script. So all we need to do is decompile that. So again, I tried a few different tools, and the one I had the best luck with, let's see, where did I put that? Local bin. Yeah, it's this one, decompile 3. That seemed to work pretty well. So let's take a look at the help for this. All right, so we need a path. All right, that looks pretty simple. So let's just call decompile 3 on this. I don't know why I had a dash there. Let's see if that works. And there we go. It worked. It just decompiled it. Now this is going to decompile to screen. Let's give it an output. I'm just going to drop it into my home directory here. And if we go back to my home directory, that's not it. There it is. Okay, well that didn't work the way I thought it was going to. I've got this file somewhere now. Let's see, what command did I run before? Oh, it needs the slash, and I think the order of arguments might matter too. I don't know. We'll just do that. That's why it didn't work apparently. Okay, so yeah, you can see the difference here. It didn't want to do the output directory, I guess, because I didn't have the slash. All right, well, that's good to know. But yeah, before it was outputting the screen, now it actually output to a file, and here we go. We have 0xfff.py. Let's open it in Vim. And here we go. We have the original Python source of Black Kingdom, some ransomware that some people have been throwing around the internet for all those vulnerable Exchange servers that are still out there. By the way, if you've got an Exchange server and you have not yet patched it for the proxy logon vulnerabilities, which came out at the beginning of March. Let's see, today is April the 10th, so you've had plenty of time. I would be very surprised if you do not already have web shells and other stuff on your servers, because everybody has been using this. They've been scanning for it. They've been dropping web shells like crazy. So not everybody's utilizing them. I think there might be a few people or a few bad actors out there that are dropping some shells, maybe leaving them for there, establishing some other backdoors, that kind of thing. Some of that's going on. So at any rate, if you haven't patched, patch. And then if you haven't scanned for web shells, scan for web shells. Even if you've patched, those shells are still going to be there. Patching does not remove the web shells. I've said this before. It's super important. Make sure you scan for those. Microsoft released several tools for this, so just do some Googling. I don't have the links handy on me. Check out the Perch blog. perchsecurity.com/blog. I put a bunch of data in there, a bunch of links to all the different tools and whatnot. So that's a great resource you can use as well. Okay, so here it is. Here is the original source code for Black Kingdom. Again, it's just a Python script. All right, so we've got, let's see, some stuff here. This is interesting. There is this function that disables the mouse and keyboard. It's using hook manager, so that's going to be a Python library, and essentially what this does is I mean does what it says. It disables the mouse and keyboard. So at some point when this ransomware is running, it will call this function. It disables your mouse and keyboard and pops up with your ransomware node. All right, what other functions we have? There's something called get string. Generate string. So this is, what is it doing? So we've got all uppercase plus digit, 64 characters. So all right, so this is generating a random string of uppercase characters, letters, and numbers. Anyway, this is end up going to be used for the key for encrypting the data. Let's see. Yeah, see, here we go. So it's calling gen string, then we're getting the UTF-8 version of that, and then getting a hex digest and encoding it. Okay, so we're getting an MD5 of the hex digest encoded UTF-8 version of the randomly generated string, and that's going to be the key that is used, assuming it passed the connectivity check. So there's a connectivity check that occurs, and when it uploads the string or the key. So the bad guy's got to keep an eye, or got to know what the key is as well. All right, then we've got all this. So this is obviously base 64. What does that decode to? Oh, that's okay. I think that's okay. I think that might be. I don't know. At any rate, this is actually a variable name. So it's taking this variable name and then it's assigning it this value, which honestly, I don't think this is actually used anywhere. So let's see, it's used here. Here we're just getting the length, and then there's a thing at the bottom that says that this global variable was never used. All right, so just some noise, I guess. Really not much purpose, and it's actually kind of repeated. Most of it's repeated down here. This is part of the ransom node. Yeah, you can see here, here's a ransom node. We hacked your network, blah, blah, blah. But this isn't actually the one that's used. I'm not sure why this is here. I feel like it's just they were doing something and then they changed it. And there's just something that got left behind, because then we actually take a variable, we call it M416, and then we do some more base 64 decode, and we've got all of that. And hold on, I had some trouble copying and pasting this earlier. So I put it in my notepad. Oops, typo. Okay, so this is the actual ransom note that ends up getting dropped. So yeah, we are back. We hacked your network. Now all your files, documents, images, databases, and other important data are safely encrypted using the strongest algorithms ever. So yeah, here we go. Then they, see what happens if you didn't contact us. Just Google Black Kingdom. So they actually name the ransomware themselves. Sometimes with malware, the researchers will assign it a name based on strings and things found in it, but these people, they're actually naming it themselves. We've actually got an email address, so a Proton Mail email address for contacting them. They want $10,000 in Bitcoin, which is actually honestly kind of low for a lot of ransomware stuff that happens. And yeah, you can't do this on your own. Notify your supervisors as soon as possible. They're going to publish it on social media. Yeah, so lots of threats here. And then your ID, so that's where that randomly generated ID gets put here, so you can have that for reference when you get that sent to them. Anyway, so that was a variable, and then of course it just decodes it like what we just did. I just did it on the command line instead of in Python, or use CyberChef a lot, but I didn't want to switch between windows. So, all right, then we get our blacklist. So these are directories that when we get further on, these are things that are not going to be encrypted. So it's going to skip these. You will see this a lot when dealing with ransomware. Some will include maybe a list of files or like maybe extensions to encrypt. I think DearCry. I think it was DearCry. Yeah, I think it was DearCry when we looked at that. It actually had like a list of file extensions that it encrypted. Essentially, when you're doing ransomware, you want to encrypt all the data, but if you encrypt the entire system, then it just will stop working. So you actually want them to be able to log on their computer and get, like, for example, the Ransom Node. So you don't want to encrypt everything. So there's stuff like the Windows directory, program files, that kind of stuff. So your programs will still operate. It's just all of your actual files and data that are important to you are gone. All right, then we get to where we're sending the key. So it's using this mega. So this is mega.io. We're logging in, and we've actually got an ID here. Let's decode that as well. Whoops. Cigar's bumping into the microphone. That's probably not good for it. All right, so we've got an email address. That's their mega ID. They log in, and then they try to upload. Let's see, we've got a timestamp. We've got the generated ID. Let's see, where was that gen ID? Where did that get generated? Okay, so yeah, I missed it. I jumped right to the base 64. Yeah, this is up here. So there's some random characters generated here as well. 20 random characters. So that's the gen ID. And let's see what this is. Where my key? Oh, okay, that's actually this function. Or no, I'm sorry. That's passed to this function. Where is that defined? Oh, okay, it's just a variable. Okay, so let's see where send key is defined. Okay, so it's all right. It's just the key. Yeah. So send key is passed key, but in this function, they're reading that variable as where my key. So that's the key that was generated. Get the username, get the domain name. All right, all that gets uploaded to Mega so that the ransomware operators can kind of keep track of who they've infected and that kind of thing. All right, so check key. This is actually where they're doing so they're just doing a basic, just a plain post to mega.io with no data. That actually may be one way you could detect infection. And then it tries to send the key, which was the function we just looked at. If that fails, then this is the key that it uses. So it's got a backup in case the generated ID, the unique ID or key fails. So we do that. And then we get into the actual encryption. Let's see. Yeah, we're using AES here. Yeah, it's pretty simple from here on out. Like I said, it's probably pretty short. It's not that complicated. It uses a AES library, which I'm sure it's imported up here somewhere. Yeah, here we go. We see we're using the crypto library. We're importing AES. So it just uses the AES to encrypt the files. Goes through, let's see, it writes that. Oh, it does stop SQL Server, so that's interesting. I imagine just so it's easier to track or to encrypt databases. Because if you try and a database is a living, breathing thing. It's constantly changing, and if you're not going through the database server, you don't want to touch the files, or you just get corruption. So, obviously, if you're doing ransomware, while you don't have to, you could just write garbage to disk and get payments, but at some point somebody's going to notice that those decryption keys don't work. So you actually want to be able to have people to be able to decrypt the files. That way people will continue to pay you. That's kind of the idea there. So yeah, if you're going to be encrypting any kind of database files, or files on a database server, you do want to stop the server first. So it just uses calls PowerShell. Again, here's something else that if you're trying to detect this, you can use your SIEM to look for this PowerShell. For example, if you had the Perch SIEM, we could find that. All right, here we're just getting files, getting a list of the files to decrypt, and I think this is actually. Okay. Yeah, it writes this. We've got a target.txt. So it's not encrypting this. I think this might be the ransom node. Well, we'll find here in a minute where that's at. All right, here we go. We've got the blacklist, which we saw earlier. Nope, never mind. Here's the ransom node. Okay, so it does drop this in the directory. If it finds that in the directory that it's currently looking at, it breaks, so it doesn't encrypt it. I think we saw this at the very beginning. I think it was the very first variable way up at the top. Nope, never mind. All right, well, yeah, here's this function, but let's see. It was, where were we? Where is that defined? Well, at any rate, it starts off with if stopping equals false, and that's just defined somewhere. I could search for it, I guess. There it is. Okay. Nope. There it is. Okay, yeah. So I guess all those variables were defined here in this section. If stopping is false, we've got the key, we've got the gen ID, all that. So it starts off as false, and then it waits 1,200 seconds from the time that the application, or from the time it starts, and then it calls disable mouse and key, sets if stopping equals true. Let's see. It is threading. Yeah, this is where we're, okay, this is dropping the thing to the file. The thing to the file, sorry. That's the, again, this is the ransom node. So this is where it's actually, they're, creating the file. So in the path that it's currently in, it's dropping that file there. Oh, yeah, and then we get to the actual where the ransom note shows up on the screen. So it changes. It calls it the fucking window. So we disable mouse and keyboard. It sets a theme. So it actually, when it does this, you get a black screen with red text that has the ransom note on it. Is what you see on the screen, and that's what all this is setting up. It's setting up that window. And again, your mouse and keyboard are disabled, so you can't do anything. I mean, you can reboot, of course, and I didn't see anything in here for where it starts on reboot. I mean, it may be further on. I don't remember if that was there or not. I'll be honest. This this came out about two weeks ago, I think. and I got a copy the day after it was first noticed, and I decompiled it and read it, kind of read through it, um, and haven't touched it since. So, oh yeah, there isn't time expired. If there is a countdown timer, and if it says the amount doubles if you don't respond in that amount of time. More scare tactics. These ransomware operators love to do anything they can to use scare tactics. In fact, recently, I think Clop ransomware they've been well, a lot of ransomware operators over the past year or so, they've been extracting data and doing data leaks and extortion. We've stolen your data. We're going to release it to the internet or sell it unless you pay us an additional ransom. So they get double the ransom. Clop has started pulling out. They take their time. They try to get customer data for whoever their victim is, get those customers' email addresses, and they've been emailing customers of their victims and saying, hey, we've got your data and we're going to release your private data, which includes maybe social security numbers or bank account numbers or whatever data they may have, unless this victim pays us. You should contact them and tell them to pay us in order to protect your data. They haven't contacted us yet. They don't care about your data. Tell them you do. That kind of thing. Really, really nasty stuff. But yeah, that's not this. This is Black Kingdom, and they have a timer, and once it counts down, then it says that it doubles. Let's see. We're stopping the SQL server. What is this? Looks very similar to what we saw at the beginning. Let's see what this decodes to. It's probably the same thing. A lot of people have been describing this as kind of amateurish, and this is probably some of the reasons why. Like there's some junk. I mean, not really junk code. Like normally, if you're a lot of more advanced ransomware will include junk code for the purpose of obfuscation. There's no obfuscation here. This almost looks like somebody's just copying and pasting something, and they're just kind of being lazy. Or reusing somebody else's code even. I'm not sure, because I don't think this does anything. It's just, we define a variable, we get the length for it, but it's not even assigned to a variable. Yeah, that's it. That's all it does. But yeah, so for Fortinet, I think this is the main function. So they don't call it main, they call it for Fortinet. Anyway, so they stop the SQL server. They've these two lines which don't do anything. Then we start encrypt. Oh, and then it clears the logs, and then we call fucking window. Let's see. So I must have passed by that function, but this is also interesting. There it is. They go through the Windows logs, so the application security and system logs, and just clear it. So that's the last thing they do. That's just mean, but that's also kind of normal behavior for a lot of bad actors to hide their activity. Although with ransomware, and since it's already encrypting the files, now the encryption process is happening. It is threaded, so it's happening in the background. I'm not sure if if you have a log agent of some kind that ships to a SIM. At one there's kind of a race condition there. Will you get the logs and send them to your SIM, or will it get cleared first? I don't know. I actually haven't tested that to see how quickly it clears those logs out. But anyway, there you go. That's the whole thing. It's very simple, very basic ransomware. Like I said, they wrote a Python script that does it. Pretty simple, pretty straightforward. Just find files, encrypt them, exclude certain things, generate ransom node. It doesn't really do much to detect if things have already been encrypted. So that's something to watch out for. It does check to see if that if the ransom node is in the directory. So it drops a ransom node in each directory with that it's encrypting. If that ransom node exists, then it doesn't encrypt it. And we saw that earlier when it calls a break when that file exists. Yeah, here we go. So it drops that. You can see here it's adding it to the path for every path that it finds. And then when it's going through those, if it finds that file in a path, then it breaks and it moves on to the next directory. But if this, for example, got deleted, then you could get double encrypted. So that's something to keep in mind. A common technique by other ransomware actors are to actually change an extension. They might put a .crypt or actually they do change the extension here. We can see here, but they're creating random extensions. This is where it's actually changing the name of the file. So with other things, you'll see, a .crypt or something at the end, and there is a check to see if it's a .crypt, then we know we've already encrypted, so we don't double encrypt it. Again, if you end up double or triple or quadruple encrypting a file, it's going to be a lot harder to decrypt, especially if it runs multiple times, generates multiple keys, and ideally, if you're the ransomware operator, you do want the files to be able to be decrypted, because then, if there are instances of people getting ransomed, paying it, and being able to get their files back, then that's more likely that the next person will pay. But if they don't decrypt, then you're kind of fucked, and nobody's going to pay you. They're just going to be really sad they lost all their data. All right, that's pretty much it. If you know where to find malware on the internet, you could probably find some copies of this. There's multiple versions of Black KingDom spreading around, and it's pretty straightforward to decompile, as we just saw. And you can kind of look through the Python code again yourself. I'm not going to upload it. I know sometimes when I'm doing stuff, I'll upload source codes and things to my site or to my GitHub, which you can access by accessing my website at bamctf.com. That's bamctf.com. But I don't do ransomware, or I don't share malware. There's other places that are safe for doing that, and if you don't know how to find those, then you probably shouldn't be looking at malware anyway. Or at least, maybe be a part of a trust group or something so other people can share it with you, that kind of thing. So that's about it for this week. Just pretty simple, straightforward malware. I'm going to take a look at that. Couple things coming up. Well, one thing coming up, I do have a CTF that I'm putting together at the end of this month, April 29th. I'm still not sure where the registration link for that is. I'm working with my company, so I work for ConnectWise. I'm the manager of their cyber research unit. And yeah, that is a recent promotion for me, so congrats me. But yeah, I'm working with them, and marketing's putting together a registration link, and I'm not sure where that's at. So I'll have to find that. When I find the registration link, I will put it up on my Twitter. That's at BAMCTF. That's at BAMCTF. If you have any content you want to see, go ahead and hit me up on Twitter, make any recommendations. I don't have any specific plans for next time, but we'll figure something out. Actually, I probably won't do anything next week, and I'm going to be out of town. And then next weekend, and the following weekend, actually what we will do is, so the CTF that's coming up the end of this month, so this is primarily for MSPs. So if you are part of an MSP or MSSP or TSP, this is the CTF for you, and we're going to be using Perchibana, which is the Perch application. So that's Perch Security, which is a ConnectWise company. That's my employer. But we're using the Perchibana platform, which is it's our own hosted version of Elasticsearch. So if you're familiar with Elastic, this will be really easy. If not, this is a great opportunity to learn how to use Elastic and how to use Perch as well. But we're working on a scenario. All the data is going to go into Perch, and this is going to be a blue team type CTF where you're going to be performing an investigation inside the Perch application. So what I will do not next week, 'cause I'm out of town, but in 2 weeks, I'll go ahead and just kind of give a demo of Perch and using Elastic and how to find things. I think we've talked about it before. We've done some other CTFs in Perch, and we've had some people on, and they've kind of talked about it. But anyway, that's coming up April 29th. I will get that link out there in the next couple weeks, and we've still got 19. Fuck, it's coming quicker than I thought. Yeah, we've still got 19 days. So I'll get that link to you or on Twitter, and you guys can register and have fun. I think that is it for now. Barely got a third of the way through the cigar. It's still really heavy chocolate. I think I'm getting a little bit of that malt now. Very, very peppery though. Very spicy. Kind of a spicy chocolate. Yeah, I like this. Yeah, so that's it for now. If you tune in 2 weeks, and if you're ever in a CTF and you find yourself stuck, don't forget to always try harder, don't panic, and always RTFM. Thanks. Bye.